Welcome, everyone. My name is Ricardo Camacho, Director of Regulatory Safety and Security Compliance, and thank you for joining us today on this webinar to go over the What's New in C, C++ Test 2022.2. I'm here with Miroslav Zielinski, Director of Product Management, and we are both very excited to be bringing you the key highlights of this fantastic release. It's going to be a very informative presentation, so let's start with the agenda. Many of you may already be aware of the latest MISRA C 2012 Amendment 3 release. We are very proud to say that we are already supporting it, and on top of that, we're also supporting a draft version of the MISRA C++ 22X. So some very exciting content we're going to have for you today. I'm jumping ahead, but one important fact is that my last slide contains a QR code to the registration page for our dedicated MISRA C 2012 Amendment 3 webinar. It is scheduled for January 12th, where Mirek and Michal, who sits in the MISRA working group, will dive into the details of MISRA C 2012 Amendment 3. You're not going to want to miss it. Continuing with the agenda, there have been some C++ test updates to the Common Weakness Enumeration, CWE, which I'll go over. There have also been baselining feature enhancements in the CI/CD workflow for GitHub and GitLab. Mirek will be highlighting this enhancement through a live demonstration in today's presentation using GitHub. There are also new capabilities around our unit testing framework in support of stubbing C++ templates. And as we always do for each release, we continue to add support for new compilers and new versions of existing compilers. After Mirek's demo, we will open things up for live Q&A. Okay, before we get started, I'm going to go through some housekeeping. As you may be aware, everybody's microphone has been muted. However, if you have questions, please enter them into the question dialog box at any time. Although we are having a live Q&A at the end, feel free to enter your questions beforehand. Also, this presentation is being recorded and will be made available typically within 12 hours after the presentation has ended. Okay, let's get started. The release of MISRA C 2012 Amendment 3 was publicly announced last week, but it was technically released in October of this year. There's a difference between the dates due to MISRA's approval process. The thrilling part is that Parasoft C C++ Test 2022.2 provides 100% coverage of all Amendment 3 guidelines, and we provide the most complete coverage that complement and enhances support for the MISRA C 2012 standard, making us the leaders in the industry. If your organization needs to comply with MISRA C 2012, this means that you also need to comply with Amendment 3. If you're a Parasoft customer, fantastic. You get to go to the customer portal and download the latest C++ test version 2022.2. Amendment 3 extends MISRA C 2012 by adding one new directive and amending 3 existing directives. It also adds 23 new rules and amends 13 existing rules. Amendment 3 continues its focus on features of the C11 version of the C programming language and has started to address the latest C18 version of the C programming language. In fact, the MISRA organization expects that Amendment 3 will be welcomed by the community at large and will offer confidence to projects and organizations who have held off migrating to C11. And for those organizations that have been using C11, today having a coding standard that strongly supports this version of the C language and in collaboration with C++ Test, it is very important because it helps ensure delivery of code that is not only safe and reliable, but secure as well. So Amendment 3 has been very much awaited, and we are very proud to have it integrated so quickly into our C++ test product and available to the software industry. Here's a visual on some of the sections in the MISRA standard. There are also no changes to the structure. You still have categories that are mandatory, required, and advisory. Each guideline is still classified as a single translation unit or system, and each rule as decidable or undecidable. There were also restrictions lifted on Rule 1.4 that were introduced in Amendment 2, but I'll leave that topic to Mirek and Michal for their webinar that's coming in January. We have evolved over the years, and today we have a powerful compliance framework. Not only do we fully support the MISRA rules, but it's also configurable. Users can enable or disable rules, define their own configurations, and even create their own rules. Also, we generate all the required reports needed to show compliance as defined by the standard. And our reporting and analytics DTP dashboard solution shows how your team is progressing towards compliance and much more. Additionally, both C, C++ Test and DTP are TÜV SÜD certified, fulfilling requirements for functional safety standards ISO 26262, IC 62304, IC 61508, and EN 50128. Certification for DO 178 is also supported, but there's a different process for which we have a tool qualification kit. My point here is that Parasoft has a complete and solid solution. You can't do any better. And I'm not just referring to MISRA C. Let's move on to MISRA C++. C, C++ Test 2022.2 covers the 51 new rules defined in MISRA C++ 22X. In case you're not aware, MISRA and AUTOSAR got together to build the next C++ coding standard that supersedes AUTOSAR C++ 14 and in turn MISRA C++ 2008. The focus is supporting C++ programming language version 2017, commonly referred to as C++ 17. As I have indirectly mentioned, Parasoft actively participates in the MISRA C and C++ working group, so we were given permission to incorporate the 51 rules that have been so far defined in the draft version of the MISRA C++ 22X standard. We are so excited for our customers and prospects to be able to announce this because so many organizations have moved to using C++ 17. Coding standard that addresses safety, security, and code quality for C++ 17 has been long desired. So we are very excited to be the first to offer this solution, which means that using C, C++ Test with MISRA C++ 22X will give a head start and leg up on satisfying compliance and delivering higher quality C++ code. So less defects, less vulnerabilities, which equates to a huge cost savings. Now, there are an expected 150 new rules once the standard is complete. The first completed version of the C++ coding standard is expected to be published in 2023. So I anticipate that it will be called MISRA C++ 2023. And to give you some additional facts, the latest version of the C++ language is informally called C++ 20. I'm sure the MISRA organization will also evolve the MISRA C++ standard in support of the evolution of the C++ coding language. Know that Parasoft will be right there as well, offering you the latest and greatest MISRA compliance solution. Again, I like to give visuals, so this slide contains a screenshot of C++ Test 2022.2 and how easy it is to select and configure the MISRA C++ 22X coding analysis. Okay, there's some other enhancements in the C++ Test 2022 release in support of security. Parasoft C, C++ Test 2022.2 has added 2 new configurations, CWE Top 25 2022 and CWE Top 25 plus On The Cusp 2022. This was done in support of our customers wanting or requiring to ensure security in the development of their software applications. Again, just like our commitment with MISRA, we stay on top of these coding standards so that our customers or prospects have the latest technology or solutions available to them. To put things in greater context, the MITRE Corporation published a CWE Top 25 updated this year. And this update includes the use of a methodology to objectively determine which CWEs are most common and most dangerous. This update brings CWE into alignment with the constantly changing application security landscape and bears in mind real problems occurring in real applications today. You're seeing an example on this change over time on the bottom right graphic. Anyway, this update also included changes to the On The Cusp list from CWE, which essentially extends the top 25 to the top 40. CWE, a common weakness enumeration, is a community-supported list of the common cybersecurity weaknesses. They have a comprehensive repository or catalog of known weaknesses known as the National Vulnerability Database. And better yet, MITRE offers a threat assessment and remediation analysis referred to as TERA. And TERA is a framework which includes a process on how to take advantage of the NVD database in identifying and assessing cyber threats, then selecting countermeasures, and then effectively mitigating those threats. Mitigating threats includes lots of testing, such as security requirements testing, unit testing, fuzz testing, and other testing methods which Parasoft provides to ensure secure applications. Here is another visual of C++ tests with the latest CWE configurations. Now, if you have not yet adopted a security compliance standard, and if you're wondering where to get started, the CWE Top 25 is a great starting point, no matter what kind of application you are actually developing. And if you're getting close to eliminating all the CWE Top 25 weaknesses in your software, then take a look at the On The Cusp rules. There are also other standards to consider, such as CERT for C and C++, the Underwriters Laboratory, UL 2900, which is a cybersecurity standard for connected devices. And in case you're also building web applications, take a look at OWASP and the OWASP Top 10. Now, I decided to put a slide on this topic because I still find it surprising that some organizations have not adopted static analysis. You have probably already seen multiple graphs and heard many times the term shift left to find defects earlier when they are actually cheaper to fix. And yes, the cost increases as you move through each of the development phases because at the next development phase, more people have to be involved in fixing the defect, so more effort, more time, scheduled delays may take place. Documentation may need to be updated, software patches may be required, and the list of issues continues to grow. And if the product happens to go out with a severe defect, then you may have recalls, lawsuits. Basically, the costs can be astronomical. In one of my previous positions, I was a project manager responsible for delivering software testing services. Unit testing the software was always the primary request, never static analysis. On one engagement, after 4 months of unit testing with a team of 6, I decided to run the MISRA C standard on the code, and in a matter of 2 hours, I found approximately 85% of the same defects we had discovered doing unit testing. Additionally, the static analysis also found other defects that were missed. So my experience and message here is that if you are not applying static analysis from the get-go, your cost of testing is not being mitigated. Adopting static analysis is very easy to do, especially using C++ tests, because we plug right into your IDE or into your build process. It's really easy. Developers are going to love this next enhancement that we have added to our modern CI/CD development workflow with GitHub and GitLab. We have incorporated a static analysis results baselining feature. And what it does is that it enables developers to receive static analysis results only on their code. So focus is on the code files that they've changed. So the scope of the static analysis results is based on the feature branch that they are working in. The static analysis will not contain violations from other files in the main branch, and better yet, legacy code. Developers are now unburdened by perhaps the hundreds or thousands of violations legacy code may contain and having to meander through them and deal with that frustration. Team leads or software managers will also realize that their developers will have a much easier time adopting static analysis and fixing violations that they can relate to the code that they actually wrote. And in a way, our static analysis results baselining is like pair programming in having someone there looking over your shoulder, letting you know that you have just implemented a potential bug. So you're actually learning from it and becoming a better software developer. And yes, I just dated myself with pair programming. It used to be a boomer technique. Anyway, you will also notice an acceleration towards compliance of MISRA or whichever coding standard that you've adopted. In addition, we have made it very easy to enable this feature within GitHub and GitLab. No configuring is needed within C++ test, and we have provided the information you need to configure this capability in the Run CPP test action, Parasoft repository, GitHub, and in the C++ test GitLab repository as it is shown in this slide. We have also enhanced our automated unit testing framework to enable the stubbing of C++ templates. C++ templates allow functions and classes to operate with generic types. This allows a function or class to work on many different data types. There is a template snippet of code at the top right of the slide. As you know, C++ code contains many procedures or functions, and they may call each other, including C++ templates, in order to fulfill complex functionality. Therefore, stubbing provides the ability to stub out functions, procedures, now C++ templates, so the unit of code under test can be exercised by isolating it. Hence, you have unit testing. Not just through stubbing out, but as part of our framework, we also provide the ability to manipulate the inputs to the units under test and examine how it behaves. This means that the user can perform fault injection testing, which is a compliance requirement for functional safety standards. Also, if functionality is not available, a user can create a stub for that missing call, allowing for early testing of their own code. This, of course, reduces costs and labor. I'll start with the main message here, and that is that we are offering our customers and prospects Parasoft C++ Test Standard Edition as a solution that now also runs on ARM-based development platforms. We have been noticing from some of our future-looking customers that they have been moving to ARM processor-based development platforms, away from x86 development platforms. This option was originally driven by ARM's lower cost and lower power consumption that has only grown because ARM is now available to compete head-to-head on performance, multiprocessing features, and other metrics as well. ARM processors are used extensively in customer electronic devices such as smartphones, tablets, wearables, and they're also actually used in a wide range of sensors and Internet of Things devices. I would argue that about 70% of embedded devices run on ARM. A couple of significant benefits to moving to ARM development platforms is the simplification of your software development workflow, because it's far more efficient to develop and test, which includes running our static analysis on your software in the platform that your application will be running on. So no cross-compiler, lower cost of maintenance, and much more. The other amazing benefit is to our customers that develop and test within an ARM-based cloud environment or want to switch to an ARM-based cloud environment. Cloud resources or total cost of ownership of ARM is 30% cheaper than for x86. So we want to make sure we accommodate our customers or prospects running on the ARM cloud or making the switch to the ARM cloud. We find a plethora of compilers that our customers use, and compilers evolve. Some of them become TÜV certified, and there's also different versions or multiple versions of compilers. Also, our customers switch compilers. Therefore, Parasoft is constantly adding new compiler support virtually in every release that we deliver. So we have added GCC for ARM64 and 2 versions of the Green Hills compiler. For the full list of compilers, visit our website, actually the product page for C++ test. You will find a technical specifications link that will take you to that list of information. Okay, let's get to the demo. Mirek, over to you.
Thank you, Ricardo. We have a lot of exciting updates in the new release. With our demo, we want to highlight 2 things. The first thing is static analysis results baselining in GitHub. The second thing is our new distribution of C++ test static analyzer that can be run on Linux ARM platforms. In our demo, we will be using the development environment based on Linux ARM with native ARM compiler, VS Code and Parasoft static analyzer. We've based it on the Raspberry Pi 4 with Ubuntu Linux. For CI/CD, we'll use GitHub with a GitHub runner also configured on our Raspberry Pi. Obviously, Raspberry Pi is a fun factor in our demonstration to visualize that development and compliance tools can be used natively also on the ARM platforms. In the real-world scenarios, you will have, say, more powerful ARM servers or cloud resources used for this purpose. In our demonstration, we'll see a developer working on the code that requires MISRA compliance. Here we have our project in GitHub. MISRA compliance scan was already executed for it. And we can see many MISRA violations reported for our codebase. This is a very typical situation. Rarely do we have a chance to work with a codebase that is 100% clean. My team has a plan to clean up everything in the long run, but to start the cleanup process, team established a policy that every new code must be 100% MISRA compliant. This policy is enforced with a pull request quality gate in GitHub pipelines. Here we have a branch protection rule defined for our main branch, which requires positive status from Parasoft C++ test MISRA checker. When merging to main, GitHub will compare feature branch static analysis results with the parent branch results. New issues will block the merge operation. The static analysis report produced by C++ test includes all the information about violations that GitHub requires to baseline the results and present to developer in the pull request only the problems relevant to the new code added in the feature branch. So let's switch now to my Raspberry Pi development workstation. For my local development activities, I'm using VS Code, and I already have a local clone of my GitHub repository here. If I need, I can execute the static analysis locally. Here in the VS Code, you can see all the violations for the project. But in my workflow, I rely on the MISRA quality gate in my GitHub pipeline. And I'm interested only in the new problems relevant for my new code. So let me create a feature branch and add some new code. Let's say we need to implement a function. Okay, just a small modification in header. And now we're ready to push our changes to GitHub. Obviously, we are interested in merging our new code with the main branch. So let's create a pull request. Okay. And our pull request triggered the pipeline with C++ test MISRA C 2012 quality gate. And because we have defined a branch protecting rule which expects the positive status from the Parasoft MISRA checker, we need to wait until the pipeline is finished. So let's see how it is going. We see that project is built now, and in a moment static analysis for MISRA compliance quality gate will be executed. Please note that all of this, including Parasoft static analysis, execute on the ARM-based GitHub runner, our Raspberry Pi. And our pipeline is done. So let's go back to the pull request page, and here we can see that we're not yet ready to merge our branch. There are some MISRA violations found in our code, which is against the branch protection rule. As we discussed, these results are baselined on our parent branch, so we see only the findings relevant to the newly added code. These all 200-something pre-existing violations are not shown here, which is a big time saver for me as a developer because I can focus only on my issues. So let's drill down for details. Alright, these issues are not very complicated. MISRA checker reports that an empty parameter list is invalid in a function prototype. So let's quickly fix this MISRA compliance problem. And we're ready to push the code back to GitHub. And let's go to GitHub. Here we can see that our commit triggered the pipeline again. We're expecting a clean run now, so let's wait until it finishes. Alright, it seems we're done. No more problems found, and the quality gate is now open. And we are free to merge our new code with the main branch. And this concludes our demonstration. We just saw Parasoft static analysis tools executing natively on Linux ARM, which is a great benefit for the teams working on ARM-based development platforms, and how close integration of Parasoft static analysis with GitHub enhances developers' productivity. Ricardo, back to you for a quick summary.
Thank you, Mirek. Development teams are going to really enjoy not having static analysis noise from the other files that actually do not pertain to their immediate work. And I like that you showed VS Code, my favorite editor, plus running on Raspberry Pi. Actually, that was really cool. That was a great demonstration, Mirek. Now, if you are a prospect and want to learn more about C++ tests, please request a custom in-depth demo. I've placed a QR code for you to follow or visit our website. There you will find a button in the C++ test product page. And for any customers, again, that they want to download 2022.2 release, please visit the customer portal. We're also starting our first 2023 webinar by featuring what you need to know about MISRA Amendment 3. And as I mentioned before, Mirek and Miha are going to fill us in on all the juicy nuances of Amendment 3. Follow the QR code on the right side of the slide and it'll take you to the registration page. Also, you can find us, follow us on Twitter, Facebook, and LinkedIn. And if you have any questions after this webinar, please feel free to send us an email at info@parasoft.com. I thank you again for attending. Bye-bye, folks.